Welcome to the Real Python Podcast. This is episode 17. Are you familiar with linear programming and how it can be used to solve resource optimization problems? Would you like to free your Python code from a clunky command line and start making convenient graphical user interfaces for your applications? This week on the show, David Amos is back with another batch of PyCoder's weekly articles and projects. David talks about a recent Real Python article about linear programming in Python. And we discuss an article titled PySimpleGUI, the simple way to create a GUI with Python. We also cover several other articles and projects from the Python community, including Python's reduce function, flaws in the Pickle module, advanced pytest techniques, and how to trick a neural network. All right, let's get started. The Real Python Podcast is a weekly conversation about using Python in the real world. My name is Christopher Bailey, your host. Each week, we feature interviews with experts in the community and discussions about the topics, articles, and courses found at realpython.com. After the podcast, join us and learn real-world Python skills with a community of experts at realpython.com. Hey, David. Welcome back.
Hey, thanks.
All right. So you ready to dive into some more articles here?
I am.
I think I'll start off today.
Okay.
I want to talk about a Real Python article. It's from Leodonis about Python's reduce function called Python reduce from functional to Pythonic style. Is talking about how the reduce function, in some ways, a bit of a holdover from the Python 2 days. Meanwhile, Python has moved on and has added a whole set of functions that are not only like simpler and more Pythonic, quote unquote, looking ways of doing these types of functional things. This reduce has sort of stayed here the whole time, which is kind of interesting. And it goes into very common things that you might have learned how to do and reduce, like simple sort of summing or creating products, or even comparison kinds of things like finding the minimum and maximum. And those have kind of become almost built-in functions that are so much faster. It goes into the end of the article, goes much deeper into showing you actually with time it, and it's dramatic. The difference going from, it was like 18 seconds down to around a second.
Yeah.
Which is pretty amazing for something like summing. And then also, it talks about other nice kind of keywords of like all or any.
Yeah.
Doing those Boolean types of operations where not only are written that sort of really fast optimized C level, but they also have exits, meaning that if in the case of something like all, where you're looking and kind of doing this sort of and type of operation, are all of these things, is this and this and this and this all either true or false or whatever. In the case of the and function, it actually will exit out immediately if it finds one that isn't, which is so much smarter than it going through the entire, in the case of a data frame or a huge iterable or what have you.
Right.
It kind of goes back into some of the stuff that I talked about in the previous episode with Hannah about working inside of pandas, and that Python again has thought of ways to make it like a little bit smoother and a lot faster and more optimized. And any's another one that's like that. It's sort of that or statement. And again, it would be nice if there's one example, then that would just exit out right away. But it's a very good article. I think it's really well written, and it really goes into all the different ways to look at it, not only with reduce, using like a standard style function, but using it with a lambda and all the other kinds of functions inside of there. And I think it's kind of one of those things that maybe help you think if you're still wondering if that's something you should be using or where it's useful to still use it, and all the options that are around, hopefully making your code a little bit more Pythonic.
Yeah. Yeah, it is. It's a really interesting article. And I mean, there's this whole, debate around the whole like map filter reduce thing and whether or not you should use it as opposed to say things like list comprehension or something, which you can achieve similar results.
Right.
It's a tool, and there are times when it might make sense to use that tool.
Yeah.
And it's good to know how it works. There's something about functional programming that I find really attractive.
Okay.
And maybe it just comes from my math background from studying mathematics for such a long time, but I really like this idea of functions not having side effects. That's something that these like pure functions, it feels much more natural to me than a function having some sort of side effect where, I mean, like a good example would be something like the print function is not a pure function, right? I mean, it sends some text to the standard out and returns the value none. So there's like this side effect of like this text going somewhere, and then it's just returning this none value. While it's a useful function, right, for debugging and for displaying output in a terminal and everything, but it somehow seems to like break this like idealized version of what a function actually should be. And so,
yeah, if you were to talk about the idea of like functional programming to kind of dive in a little deeper, like one of the core sort of tenets of it is that it's not affecting the inputs.
right.
And so that you're basically, say you're inputting A and B will be what they are at the same as they are if at the start at the end after the function has run.
Right.
Okay. Am I missing anything else are there other core tenets about functional programming?
Well, I mean, that's a big thing is, not affecting the inputs and always having an output. But there's other things like there is sort of a focus on like these lists and arrays as the primary data structure for processing and everything. Recursion is something that's used quite a bit in
that was the one. Yeah.
Functional programming. Yeah. In my mind, I always think of it as like the pure functions. And I guess it's one of those things when I, was studying computer science in university and talking about functions and side effects, it was sort of like, wait a second, like this feels dirty. Like this shouldn't be. Again, I think that's just sort of the mathematical side of me coming out. I mean, I break my own values, I guess, all the time in my own programming. And that's just something I've always found real attractive about functional programming. But yeah, this is a great article. And I also like that he compares reduce to the accumulate function from the itertools module.
Yeah. Yeah, which is new, right?
I don't know that it's new. The accumulate function or?
Oh, I think the product is the newish one.
Prod?
Yeah, prod. Function? I mean, yeah, I'm sorry.
Okay, the built-in. Yeah, it's a sort of a complementary to sum. So instead of summing over.
Coming with the math module.
Yep. Yeah, that's a cool new addition.
Okay. Cool. So what do you got?
So speaking of math, I guess it's a good segue into my article. I've got one from Mirko on the Real Python team. And Mirko, next time we chat, I need to learn how to pronounce your last name. I'm not going to attempt it right now, but I hope to learn. So in the future, I can correctly pronounce it because we will probably feature more of his articles.
Yeah.
He's got this great article called Hands-on Linear Programming Optimization with Python. So this is a topic that's actually pretty near and dear to my heart. I've done not a massive amount of linear programming, but it's a tool that I used quite a bit when I was studying mathematics, and in particular studying graph theory, which maybe we can talk about when I'm done going through the through the article. But linear programming is a way to take like a set of linear equations, which are things like ax plus by equals c. That's a linear equation. You have variables that don't have any sort of like exponent on them, the x and y's, and they have some coefficients and they're equal. Or you can have linear inequalities where that expression of x and y or however many variables you have is like less than or equal to some number or greater than equal. But you set up the system of equations or inequalities, and it's subject to some constraints. So a good example would be I'll use the example that he's got in the article. So the example he gives is a resource allocation problem. And I'll just, I'll read off a little bit here. So say that a factory produces 4 different products, and the daily produced amount of the first product is X1. The amount produced of the second product is X2. And then for the third and fourth to be X3, X4. So these are your variables.
Okay.
And the goal is to determine the profit maximizing daily production amount for each product. So you want to know how much should I produce each day to maximize my profits. But there's some constraints. And so the constraints are, for example, what the profit for each unit of each product is. So like maybe product 1 has a profit of $20 for each unit when you sell it. Product 2 has $12, product 3, 40, product 4, 25. These are just some arbitrary values. And you know that you can only produce so many units like in total each day, right? I mean, because you only have so many people that work for you, you have so much capacity. So let's say maybe that's 50. And then each product has raw materials that are consumed when you produce that product. So you have a couple different raw materials that are used in each to produce all 4 different products, and they vary in how much amount, and the amounts that you need for each product. So you have this giant system of linear equations and these constraints and everything. And the idea is I want to find out how, knowing all the things that I do about this, can I figure out how much of each product I should produce every day to maximize my profit? So this is an optimization problem that can be solved with linear programming. Mirko goes on to describe a couple of different ways that you can approach solving these kinds of problems using the SciPy library, and also one called Pulp, or PULP, which I spent a little bit of time trying to figure out what the U in Pulp means, and I couldn't figure it out. I mean, I think LP is for linear programming. PU, I'm not sure. Python.
It's probably Python, and they just like added a vowel to be able to pronounce it.
Yeah, I'm not sure. Yeah, that's probably the yeah. But he goes through solving the same problem using these 2 different not methods, but 2 different libraries. So in SciPy, and there's some differences. So that are kind of interesting. In SciPy, it's like a function called linprog, the linprog function, and you pass to it. You have to, do some setup. You have to, and it's all like lists or list of lists to define like the different coefficients in these equations and the different values that they're supposed to be equal to, and all your constraints. So you set up all these lists and matrices, and you pass them in as arguments to this linprog function, and then it returns an object that has different information about the solution to the problem in it. So you get like the values of which you're looking for, assuming the problem can be solved. Not all linear programming problems are what we call feasible or have feasible solutions. So it could be that it can't be solved, or that no solution exists, or something like that.
Okay.
But if it can, then yeah, you get this object back, and it tells you, okay, here's what the solution is, the different values for your variables that optimize whatever your problem is, and some other information about the solution and different things about it. But the Pulp library takes a more object-oriented approach. So instead of having like this function, you build up a model that contains all the information about your problem, and then, which is like this model object, which actually it's called an LP problem. That's the class name for these objects, LP problem object.
Okay.
And you build it up and provide it with everything, and then you call the solve method, and it will attempt to solve the problem for you. And then once it's solved, it assigns like some new attributes and stuff on the model object containing the output of the problem. So kind of 2 different approaches to doing that. One is, I guess, more not necessarily functional approach, but using just a function, and the other is a more object-oriented approach. So both approaches, SciPy and Pulp, and there are other ones, none of these are actually doing anything in pure Python other than assigning values and stuff like that. Linear optimization requires much more speed and than Python could give, just pure Python by itself. So they're all calling these lower level C and C++ libraries that are doing all the heavy lifting for you and communicating with that. So he goes into some detail of what those libraries are and different options. And you can, for example, if you have a preferred solver, that's what these things are called, that you like to use, you can define and tell Pulp, like, I want to use this one instead of maybe the default one, and things like that. So there's definitely some customization that you can do there. And he provides a whole bunch of resources at the end of the article to learn more about linear programming and the different kinds of, he has a whole big list of the different solvers that you can use. This is a very practical problem. I mean, this is something that's super important in industry, in science, all sorts of stuff. I mean, linear optimization problems include like the resource allocation we talked about before, but also things like assigning workers to jobs is a linear optimization problem. scheduling is a linear optimization problem. So yeah, it's lots of practical applications. It's a big area. If you've ever heard of like operations research, it's used quite a bit in that field.
Yeah. So my next one is from Ned Batchelder, and it's called Pickle's 9 Flaws. And if you're not familiar with it, Pickle is a module in Python that is like a convenient way to serialize or deserialize objects. And if you're not familiar with Pickle in general, we have a real good Real Python article on it. And it actually covers a couple of these things that are in this article. Also, one of the problems that Ned sees in it is that there are some flaws that you really need to think about before you decide to use it. The first one is that's the most important one, that it's insecure.
Yeah.
And it's insecure in a way that you don't know exactly what's inside of it. So if you're getting this pickle file from, or this pickle object from someone else, when it expands out, it can execute a certain amount of code as it is deserialized, and malicious things can be set inside of it. And it's something to be really cautious of, kind of in the same way that, like opening attachments can be, or, opening files from odd people, or clicking on things on the internet in kind of the same way. So it's something where, if you're working within an office and passing these things around, then that's probably okay. But
yeah,
using something out in the wild is definitely not suggested for this technology.
Yeah. In the Python docs on the Pickle module, right at the top, there's a big giant pink box that says, "Warning, the Pickle module is not secure. Only unpickled data you trust." So yeah, it's a well-known issue with Pickle. Yeah.
They store the structure of your objects. And so old pickles still look like old code.
Yeah.
And so it's kind of a bit of a time capsule as far as your programming. If you move forward and maybe change things about, structures, especially like object structures and stuff like that, the pickle is not going to be updated that way.
Right. Yeah.
So something to pay attention to. They're implicit. It has to do with like, the types of objects that are putting into it. If you're working with date times, and you want them to be formatted differently, you don't really get a choice. They're going to be date times. It over serializes things. Again, it's partly because they're implicit, that they serialize everything inside your objects, even the data that you maybe didn't want to serialize.
Right. Yeah.
So something to think about. And then this kind of goes back to the object thing again. Pickle stores an entire structure of your object. So it doesn't actually call an init method, since the object was already created. And so if you had planned in your object-oriented design for when objects are initialized, it to set up things and prepare certain, parameters or just structural things, that's not going to happen when it's unpickled. It's already going to have an existing object. So that is something to plan for. They're Python only. And so a lot of people think of like comparisons of like, what else could you use instead of pickles? Like JSON is, I think, of the most popular one as far as like a serialized object.
Yeah.
For, sending and receiving data. And of course that works across, even though it is JavaScript object notation, it's very popular in almost every language that I can think of. So
yeah,
especially the web. They're unreadable. It's a binary data stream. So it's not something that you can kind of do any kind of inspection and see kind of what's in it without, unpickling it. And they're slow. And so that's one of the other main things to think about. There are some recent optimizations, and in the comments on the article, somebody talks about, well, it's, this is a little faster now. And generally compared to many other serialization techniques, it can be considered a little bit slow. If you want to learn more about the technology, or you're in an environment that's using them and you want to learn more about it, again, we have an article that came out in April, a good article to learn a little bit more about pickling from, is it David?
Oh, Master Mateo. I think that's how you, yeah. Mm-hmm.
Yeah. So again, something to learn. And again, there's a lot of the warnings there.
Yeah.
And in that one, he talks about a thing called dill, kind of going a little further on the metaphor.
Right. Yeah.
Which is about helping a little bit with the functions and serializing a little more pieces of information if you need it. So, some things to be paying attention to if you're interested in using that technology for serialization. And I know of some of the data science areas I was working with, they were using inside some of the Jupyter notebooks. Most of the work I've done has been kind of web based. And so I've mostly done stuff around JSON. Have you used the Pickle stuff a lot in your programming?
Not very much. No.
Okay.
I've generally stayed away from it. And actually, the two problems that I ran into with Pickle when I did play around with it for some stuff that I was doing was the fact that it serializes the entire object and then later changes if I changed a method.
Yeah.
Or changed an attribute name or something, or it would break the pickle and it wouldn't, right? It doesn't get updated. So that was something I ran into. And then also just the size of it is just really big.
Yeah.
And I guess it's attractive that you don't have to like do anything other than just like pickle it. Like you don't have to tell it like what data types things are, or like,
yeah.
So there's kind of this nice, like it's super easy to use and that's attractive, but
yeah, I think that's why it might be as popular.
Yeah. But the downsides, I think, outweigh the positives for most cases. I wanted to say, I'm not really sure what the deal is with the pickle name and then dill, like these food names.
Yeah, it's pretty funny.
But and then continuing on that end, it's not pickle related, but it's food related too. There's a great serialization library called Marshmallow.
Yeah.
That
I get where that one comes from, because you're serializing, which is another term is called marshal.
Marshal, yeah.
Yeah, marshaling. So you're kind of like getting all your data in line, ready to march and head a certain way.
Right, yeah.
Which I guess is the idea of, serializing. So
yeah. Well, I mean, the nice thing about like Marshmallow is, so it's a little bit more involved. I mean, you have to set up these serializers that do the serialization and deserialization, like converting the serialized form and then back into a Python object for you. And it takes some time to set up. You have to, the data types and everything, but you get a lot of like validation out of that. And so you can validate input that's coming in on, serialized input.
Yeah.
Which is really nice. Or even validation on the output stage. Like you try to serialize something and it won't because it doesn't validate. So there's some really nice extra features there that make it really, really handy.
That was the technology. Talking to Doug Farrell about the Python REST APIs. In his whole series of REST API technology, the Marshmallow is the one that he was using a lot.
Yes.
And I think it's partly the idea of, again, APIs and making sure that everything is, if you will, documented, as far as types and things like that, which is really crucial.
Right.
Yeah. This week, I want to shine a spotlight on another Real Python video course. It's about a useful built-in Python tool for creating iterators and solving common programming problems like creating dictionaries. It's titled Parallel Iteration with Python's zip function. The course is based on a Real Python article by Leodanas Pozo Ramos. In the course, instructor Liam Pulsifer takes you through how to use the Python zip function for parallel iteration, how zip works in both Python 3 and Python 2, how to loop over multiple iterables, and perform different actions on their items in parallel, and how to create dictionaries on the fly using zip. I think it's a worthy investment of your time to understand this powerful tool for creating iterators in Python. And like most of the video courses on Real Python, the course is broken down into easily consumable sections, and you get code examples for the techniques shown. Check out the video course. You can find a link in the show notes, or you can find it using the newly enhanced search tool on realpython.com. All right, what you got next?
Next one I've got is an article from Martin Winkle called Advanced PyTest Techniques I Learned While Contributing to Pandas. PyTest is one of my favorite Python packages. It's definitely my favorite package for testing. But overall, I just think it's a really cool package and it's just amazing.
Yeah.
From someone who originally learned about unit testing in at university, taking a Java class and using like the whole JUnit framework and everything, and then coming to Python and learning about unit test and all this. When I discovered PyTest, I was like, oh man, this is so much easier, so much nicer. It's it's really just a joy to work with when you're doing testing. So
that's great.
Martin talks about a few different, I guess, more advanced techniques. So if you're not familiar with PyTest, some of this may not make sense. And I got to say, if you haven't learned about PyTest, we've got a couple good articles on Real Python about that.
Yeah, we have a video course on it. And then I talked to, I think one of the big ones is the whole getting started with testing.
Yes, from Anthony Shaw.
Yeah, and we had him on the show not too long ago talking a lot about it.
Yes,
so yeah, it's a great tool.
Yeah. So we've got the course test-driven development with PyTest, which is a good course there. Yeah.
Yep.
And effective Python testing with PyTest, and yeah, all sorts of. We've got quite a few on the site. So these are some more advanced techniques, and I'll just go through and mention the ones that he talks about. So the first one is parameterizing your fixtures. And I guess to sort of set the stage for this, one of the like hallmark features of PyTest is parameterization of your tests. So if you have a test function, you can actually set up a parameterization that takes like you think of it as like sort of taking a list of the inputs you want to feed into that test case, and it'll just automatically go through and feed those inputs in and run the function on those as like its own individual test case. So it's a way to only have to write the function once and then test it with a bunch of different inputs instead of having a whole bunch of different test cases that you have to write that all have very similar code. You're just sort of changing the inputs. So this is a really powerful feature. But going a step further, you can parameterize what's known as fixtures. So a test fixture is like a piece of data that can get passed to a test as for some sort of like input. So it's actually a function that you define, and there's a little decorator called pytest fixture decorator that says, okay, this function is a fixture. And then when you pass that function by name into a test case, it'll call that function and use the return value in the test. So it allows you to sort of separate like the data from your test cases. But these fixtures, so if you want to say maybe you have a test that wants to, this is the example he gives. This is a really simple example using pandas. And you have a test that you want to, let me back up a little bit. Pandas has a whole bunch of different kinds of indices, right? You've got like a Unicode index, string index, date index, time delta index, and I mean, just you have a whole multitude of different kinds of indices. You want to test that each of these different, I guess, subclasses are like, test that each of these things are a subclass of like the index class or are an index. So how would you go about doing that? Well, you could write a whole bunch of separate test cases that go through and just test each one. But now you have, I don't know, a dozen or 15 test cases that you have to maintain with all very similar code. The solution that Martin proposes is creating a fixture function that uses a dictionary to contain all the different kinds of indices that you could have in pandas, and parameterize this function so that when it gets passed into a test case as a single fixture, it'll go through and run that test case on all the different items in this dictionary. This is a really nice way to keep your data separate from your test cases, but also not have to have a whole bunch of duplication in your test code. So yeah, really cool technique. And then when you combine fixture parameterization with test parameterization, you can get into, I mean, like really powerful stuff where you've got like a testing matrix, basically, where you're testing a whole wide array of different cases with just a single test function, which is super cool. So that's a neat concept. The next one he talks about is setting IDs in parameterizations. So when you run PyTest, you get some output that shows you like what tests have run and whether or not they passed or failed. And if you run it in like a verbose mode, it'll show you it kind of works, it kind of doesn't. It'll show you like the inputs for that particular test case, but it auto generates the names for those inputs. So I think it defaults to like either the string or the repr for whatever object is the input. And so sometimes that's helpful, sometimes it's not. So by setting IDs in your parameterizations, you can customize what that output will be in your test output and make a lot more friendlier output for people that are looking at the test as they get executed. So that's a cool.
Yeah. Or even yourself.
Well,
if you're running it later. Yeah.
Absolutely. The next trick he talks about is calling skip or xfail inside of a test. And so this was something it never even occurred to me that you would do this. PyTest has this decorator that you can set on a test function that'll tell it to like skip it or tell it that this function is expected to fail. Like this is a case in which, so if the test case fails, that should actually be a like success. Does that make sense?
Sure.
That's what the exfail is, expected to fail.
Okay.
So normally you would use these as a decorator, but it turns out that you can actually call those inside of a test function, like based on some condition. And so then it'll just skip it, but it might run. So for example, if you have a parameterized test, but you need it to skip for certain kinds of the certain parameters, then you could skip based on those. So he does have a note here which says, okay, it's great that this is possible, but the downside is that it may affect the performance of your test. Like it may slow down your test because the test suite has to do all this work to actually set up the test function and set it up for running. So if you have a decorator that just says skip this entire function, it'll never even get set up. But if you call the skip or exfail inside of, well, I guess that mainly applies to a skip. If you call it inside of the function, then it goes ahead and does all that setup work. So you kind of have to like make sure you really are using it when you should. And maybe it makes more sense to use it as the decorator instead. Another really cool feature that I'd never heard of was indirect parameterization. And this one is super cool. And I'll probably start using this. But so if you have a fixture that's been parameterized and you want to pass only certain parameters from that fixture into a test function, then you can use what's called indirect parameterization to basically select the ones from that parameterized fixture that you want to use. And that is super cool because then you don't have to write any like logic inside the test function that's like excluding any like cases that you aren't interested in, which is just, clutter, which shouldn't be there. So this is really cool. The last one he talks about is pytest raises versus null context. And so this is if you want to test that doing something in your code raises an exception. Sometimes in those kinds of tests, you want to pass it a case where it doesn't raise the exception. And you want to say, well, in this case, it shouldn't have gotten it. But in the other cases, it should have. So how do you do that? There's not really a good way because so the way that pytest.raises works, which is the function you use to test that something has actually raised an exception, is you pass to that the exception that should have been raised. Well, what exception do you pass to it when it shouldn't raise an exception? It doesn't work. So there's this object called null context that you can pass to it. And in that case, it'll tell the pytest.raises function that actually, in this case, it shouldn't have raised an exception. That's kind of a neat little trick. This one also comes with kind of a note or a warning that says, please don't overuse this feature. It can be an elegant way for simple use cases, but it could also encourage you to use parameterization for disparate behavior where separate tests would be more appropriate. So in some cases, you would probably want to separate the tests, right? That say, okay, if in these cases, it shouldn't have raised the exception. So I'm going to test that it did whatever it was supposed to do. And then in a separate test, you're going to test that the exception was raised. So again, it's one of these features where it's like, it's great that it's there. There's probably some cases where it makes sense to use this, but be careful and make sure that you really are separating concerns and organizing your test suite in the best way possible.
Yeah, it sounds like, maybe in a first pass, you could use this stuff to kind of help you get going on it. But if you have some really specific concerns, that you're still going to want to address those.
Right. Yeah.
Yeah. Okay. So my next one is from Mike Driscoll, and it's about PySimpleGUI. It's another real Python article that recently came out. And, the subtitle is the simple way to create a GUI with Python. I have been playing around with GUIs a little bit. I mentioned earlier that I was working on a WX Python course, and that's actually based on an article from Mike also. And Mike, it seems to be like a little bit of his hobby. He really is into GUIs and building these kinds of things. And PySimpleGUI is really, really simple. Like you can create a GUI in a couple lines of code, which is sort of shocking, where you don't have to do so much of all this kind of really intensive specification of all the different parameters of, the sizes of things and so forth. It does a lot of the heavy lifting for you, which is really kind of nice. I'm reviewing a course that's going to come out. I think it may come out 2 weeks or so. Maybe by the time this one comes out, it'll be out. It's about projects. Basically, if you're an intermediate developer, you may be interested in doing more with Python. And very often people don't know, what what are the kinds of things that I could do? And this whole course goes into it. And in it, Darren Jones goes into showing a whole bunch of different ways to do it, and he uses PySimpleGUI for a lot of the examples. And so I was very impressed with it, and I like the sort of the elegance of the code and kind of how quickly you can kind of get up and running with it. In the article, do the standard sort of hello world, just creating a screen, and then you get into some basic UI elements with like buttons. Within a couple examples, you're right away into creating a photo viewer or image viewer,
Yeah.
with like a browse button and looking in folders and stuff, and very simple to kind of get going. Hence the name, right?
Yeah.
And then doing some other visualization stuff with it, with some graphing, matplotlib, and NumPy, and kind of combining those things to kind of give you some more examples of types of things that you can do with it. Goes into like an OpenCV computer vision example also, which is pretty interesting. Links to a whole bunch of additional resources to kind of let you dive further into it. It ends with a little bit of time talking about PyInstaller, which is a nice tool for, especially like on Windows and stuff like that, where you may I was working in an office environment where I wanted to be able to create basically a click on executable file for a Python
Hmm.
program I've created. Something like that image viewer is the one that he uses as an example, and be able to create a double clickable executable file that you could give to somebody. And there's lots of little caveats there, but it's nice that you can kind of see that from beginning to end, the whole work through inside the article. And
Yeah.
yeah. So PyInstaller is one of those, and there's some other ones that are out there that can help you with that idea of like creating an installable. It's definitely one of those things that I know people are thinking about, and thinking about trying to find some other guests and stuff to talk to about that world of like let's create things that we can do outside of working inside of an IDE, so you can share your code with other people that are trying to check it out outside of the web. The web is probably the easiest way,
Right.
Flask and Django and stuff like that. So but yeah, it's really well done. Mike always does a great job of getting people in and creating things pretty quickly.
Yeah. I love how, like you said, end to end this article is. It's actually kind of surprising that, I mean, you've never heard of PySimpleGUI before. And okay, in this article, we're going to show you how to use it. You're going to build an image viewer, and then you're also going to build an application that can like talk to your webcam
Yeah,
and show you an image of yourself, and you can set parameters and stuff on it, and then learn how to like make it installable. I mean, that's and it's like not a terribly long article.
no,
It's not super short either, but it's a good size article. Probably take you, I don't know what you think, maybe an
yeah.
hour.
If you're running if you're typing in the articles, code and stuff,
Right. Yeah. If you're typing everything in. Yeah. I mean, it's a good like afternoon project. So yeah, it's just, and I think that's a testament to the simplicity of PySimpleGUI as well.
definitely.
As well as, Mike's writing
Yeah.
and everything. So,
So your next two are kind of connected, you're saying?
well, I mean, speaking of, I guess like computer vision and images and everything, this is an article called "How to Trick a Neural Network in Python 3" by Alvin Wan, and this is from the Digital Ocean blog, which they've got a bunch of cool stuff that you can check out on their blog. But this is about fooling a neural network that has been trained to recognize images, and how you could fool it into incorrectly recognizing an image of something. So you've got this neural network that's classifying images of animals.
Okay.
The example that he gives is you've got a picture of a corgi,
Okay.
and when you pass it into, which are awesome dogs,
Yeah.
and every time I see a picture of a corgi, there was this like video that was viral for a little while of like this corgi doing like a belly flop into a lake or something, and that just always pops into my mind. You just can't help but laugh when you see corgis. But anyways, so you feed this image into the classifier, and it comes back and says, "Hey, that is an image of a corgi."
Yeah.
And it actually identifies not just that it's a dog, but it actually identifies the breed and everything. But it can also do lots of different other kinds of animals. So in this tutorial, you learn how to apply. You take the image and you load it into Python as like an array of numbers, like a NumPy array, and you apply a simple transformation which they call perturbation to the image, which changes some of the values in a slight way.
It perturbs it.
It perturbs it, yeah. And then you save it back as a PNG image, like the original. And now, if you compare that image to the original one, you can't say like, oh, this is the one that was perturbed. Like,
right.
It's not possible to see the difference. But when you feed it to your neural network, it comes back and says, oh yeah, that's a goldfish.
That's so crazy.
So this is a big area of research. Like it's one of these things people know that, neural networks, as powerful they are, they're very susceptible to these kinds of adversarial attacks. And there's a whole bunch of research going on into how to defend from these kinds of attacks. And so for images, it turns out that one of the best ways you can defend, well, I don't know if it's one of the best ways, but a simple and effective way to defend from these kinds of image attacks is to take the input image and compress it using like JPEG compression.
Okay.
And then do your classification on the compressed image. And I guess the reason that works, I did a little bit of research to try to understand like what's going on with that. And I didn't have time to get into all the, nitty-gritty details, but in essence, when you compress an image, you're removing a whole bunch of data and just focusing on what like the dominant data is, right?
Yeah, it's very lossy, huh?
So the idea is you're removing all that perturbation, and so that the image that you get only contains like the dominant data then used to do the classification on. So that's one way you can defend against these kinds of attacks. And so you can imagine that these kinds of attacks. In this example, it's kind of funny. I mean,
right?
You're mistaking a corgi for a goldfish,
yeah.
but you can imagine that this could be used for sort of evil purposes, right? I mean, if you're fooling, I don't know, a camera system into recognizing someone as someone else,
yeah,
to gain access to like something, or so there's you can imagine there's all sorts of terrible scenarios where this could lead to bad things happening. So
right, security, thinking of all the ways that things can be abused, and this is in the data, like just subtly perturbing it, as you said.
Yeah, and so to the human eye, you there's no difference. I mean, you can't perceive any of these changes. So
almost like watermarky kind of stuff.
Right. Yeah. Yeah. So this is a really interesting tutorial. It walks you through step by step kind of how to do this. It's not, you're using like a pre-trained model and everything. So it's not walking you through the development of the actual neural network and everything. It's focusing on this adversarial example and how you create it and the perturbation and all that kind of stuff. And then it's got some links to like explore further.
Yeah.
To get more information on how that perturbation really works. And I did a little bit more research, and there's this compression idea is, I guess, pretty popular. And so there's all, this article, they just used like standard JPEG compression, but there's like a bunch of different compression algorithms that have been developed to help defend against these kinds of adversarial image attacks.
Okay.
Yeah.
So the project you were going to focus on.
Yeah. Project time.
Yeah. Awesome.
Yeah. And so it's again, in the whole attacking a neural network phase, it's called TextAttack. Let's see, the organization on GitHub is called QData.
Okay.
And it looks like maybe they're associated with computer science department at the University of Virginia. But they've got this project called TextAttack, which creates adversarial examples for NLP models. So this would be if you have like a question, an automated question and answer system, or like a little chat bot that you've created, and you want to see if it's susceptible to any sort of like adversarial attacks against it, that it could incorrectly classify language as positive or negative or something, then this text attack will generate a bunch of adversarial examples for you, and you can use it to test your model, and to also train your model if you want to like retrain it on a different data set. And it looks like a lot of it is related to, I don't know if it's related to, but they do a lot of, on the README, it talks about how they've used it to generate attacks on like the BERT model, which is from Google.
Is that like a chat thing, or what is it?
No, BERT is, and I forget what it stands for. I should look it up here. But it's a way to pre-train a text, an NLP model. And so one of the issues, right, with neural networks for like NLP is that there's not a lot of training data. I mean, depending on what your goal is with the neural network, but it could take a really long time. Like if you were wanting to create a self-contained speech recognition
Sure.
thing that you're going to run on like a server in your house. Well, where do you get the training data, right?
Yeah, the huge chunk of data. Yeah.
You're going to spend all that time just training it yourself. It's going to take years, maybe, right? I mean,
right. If it's just you, yeah, exactly.
Yeah. So, I mean, BERT is a way to provide pre-trained models.
Okay.
When you don't have that data available. This TextAttack has been used to expose like some attacks on that and other models. Yeah, it's kind of a neat tool. So if you're into NLP and want to check that you've got like a chatbot or something or some other system you've developed and want to see if it's susceptible, then you can very easily test it with this TextAttack.
Oh, cool.
Yeah.
Yeah. So my project is following the security and thinking ahead. It's on GitHub. The organization is malwared, like malware with a D at the end, and malwared LLC.
Yeah.
And they have two primary pinned projects. One that I'm going to talk about is called Build Your Own Botnet, but they have another one that's kind of interesting too, that again, if you're interested in security or penetration testing or the kind of preventative steps that you and your organization may want to think about, prepare yourself for. And that one's called the Backdoor Access Machine Farmer, which looks kind of interesting too. So both of them are on GitHub, but the Build Your Own Botnet one, it's an open source project that it's going to provide a framework for any kind of, again, people that are doing security research, or if you're a developer and you want to understand how botnets work and what's the sort of sophisticated malware that's out there on millions of devices, especially with the Internet of Things. There's a lot of stuff that you may have heard of botnets being created on and so forth. And there's a web GUI and a dashboard. Inside of it, there's everything from modules for keylogging and screenshots, webcam, encryption stuff. And it's a pretty elaborate project that kind of goes into all these different things, stuff that you need to think about. Even there's a module about iCloud and checking for, people that are logged in to that, which is pretty interesting.
Yeah.
I've had multiple people ask me questions about bringing somebody on about security, and I'm still trying to find the perfect guest for that. So I will keep looking. But if you're interested in the topic of security and Python and using it for things like penetration testing and, making sure your projects are secure, I think this is a really great project to kind of look at.
Yeah. There's I feel like whenever we share these kinds of things, we should always, and there's a big disclaimer on the top of their README that says, look, this project should only be used for authorized testing and educational purposes.
Right. Exactly.
It kind of goes, there's this greater discussion of, it's good that this stuff is in the open.
Right.
And the more that this is available, the better we can build like more robust and more resilient software, because we have these tools to help us understand how it's susceptible to attacks. But, these things can be used for destructive purposes. So
yeah, hence malwared.
Yeah.
Yeah,
exactly.
Definitely.
So if you use this for like some sort of like DDoS attack on someone,
yeah,
you're a bad person, and we never told you about it.
You didn't get the information from us. It was on the web.
Yeah.
We told you to use it for good.
That's right. Yeah.
And
always use it for good.
Yeah, there's a Discord server they have also that, where you can kind of get in and learn a little more about the discussion behind it. So if you have questions about it. Well, cool. Thanks for bringing all that stuff in again, David.
Yeah. Thanks for hanging out. It's a good time.
All right. I'll let you go.
All right. Take care.
All right. Bye. I want to thank David Amos for coming on the show this week and bringing along all those great articles. And I want to thank you for listening to the Real Python podcast. Make sure you subscribe to the podcast in your favorite player. And if you like the show, leave us a 5-star rating and a review. You can find show notes with links to all the topics we spoke about inside your podcast player or at realpython.com/podcast. And while you're there, you can leave us a question or a topic idea. I've been your host, Christopher Bailey, and look forward to talking to you soon.